वीडियो में हम इनिशियल और फाइनल वैल्यू थ्योरम ऑफ लैपलेस ट्रांसफॉर्म डिस्कस करेंगे। आपको वीडियो पसंद आएगा, आप लाइक करिए, शेयर करिए, चैनल को सब्सक्राइब करिए और डू नॉट फॉरगेट टू प्रेस द बेल आइकन। The initial value theorem is defined by if x Laplace transform of xt is given to us, that is xs, then the x 0 positive is equal to limit s tends to infinity. So, two conditions are must be applicable to a function when we are going to find it out the initial value. First condition is the first condition is applicable only when the xt is 0 and t is less than. The initial value theorem is applicable only. Second condition that xt must not contain any impulse or higher order singularity. Higher order singularities at t is equal to, it means signal discontinuous नहीं होना चाहिए at t is equal to 0. By definition, the Laplace transform of d by dt xt, और अगर हम डिफरेंशियल प्रॉपर्टी भी यूज करते हैं so that is given by s into xs minus x0. By definition, we can write 0 to infinity, that is d by dt x is a function of time e raised to the power minus st dt. Now, as we can divide this integral into two parts, because if we are talking about the 0 point, which is time axis, and this origin is a 0 point, then just before this 0, we are having 0 negative, and just after this, we are having 0 positive, and after that, we are having the value. So for that, we can divide that integral into two portions. One is 0 negative and another is 0 positive. And d by dt of x is a function of time e raised to the power minus st dt. And integration 0 positive to infinity dx by dt multiplied by e raised to the power minus st dt. Now, this O 0 negative and 0 positive are very close to each other, so we can assume that this is 0, equivalent to 0. We can say that O or 0 negative and 0 positive are very close to each other, so we can assume that is equivalent to 0. So if it is equivalent to 0, then we can say that e raised to the power minus st, e raised to the power minus st, जब हम at t is equal to 0 अगर हम कैलकुलेट करते हैं तो this is comes out to be 1. So this at t is equal to 0, this comes out to be 1. So for that, we can extend this expression like integration from 0 negative to 0 positive, that is d by dt of x dt, that is added with 0 positive and infinity d by dt of x t e raised to the power minus st dt. That's how we can write it. Now this integration landed with x with the limit 0 positive and 0 negative, and plus with the same integration we are copying from the above, that is given by. Now I'm going to put the limit, and that limit will give us x0 plus and minus x0 negative plus integration from 0 positive to infinity d by dt of x t e raised to the power minus st dt, and that is equivalent to this term, and this is rewriting here, this is s xs and minus x negative 0. Now this and this cancel out, and we are landed with the s x s, that is equal to x 0 positive plus integration from 0 positive to infinity d by dt of that x t and e raised to the power minus st st and dt. That's how we can write it. Now further, we can take the limit limit on both sides. That limit s tends to infinity s xs, that is equal to, this is the constant term, so there is no need to take here, and no s is present there. So here we can take 0 positive to infinity. In the first part there is no s term present, so we can write as it is the d by dt of x t. Now we can take limit s tends to infinity e raised to the power minus st dt. That's how we can take. Now if I am going to take the limit of this, and this e raised to the power infinity, that leads to 0. So that leads to 0. Then we will have the limit s tends to infinity sx is equal to x0. The whole integral will become 0. And that is nothing but the initial value theorem which we want to find out. It is a very important theorem as far as the Laplace transform is concerned. Another theorem we are going to do is final value theorem. For final value theorem, it is defined like Laplace transform of x t, that is equal to x. If it is given, then the x infinity, that is equal to limit s tends to 0 sx. That is property of Laplace transform, the final value theorem, and that is equal to, if I am going to take limit t tends to infinity xt. So that is the final value theorem. Now we are taking the condition. The condition is the first condition. It is applicable is applicable only when xt is equal to 0, xt is equal to 0 when t is less than 0. Second condition is very important. We have to check for each numerical or each problem given to us that S axis must have poles in the left half of the S plane. So we have to see that the left half of the S plane is having the pole or not before doing any kind of uh, problem. And for the first condition, if the ROC is given, we have to check the ROC also. Now the proof of this is given by the differential property of the Laplace transform. Laplace transform of differentiated signal x is given by s xs minus x 0 negative. That is the property of the Laplace transform, and that is equal to, by definition, can be written as integration from 0 to infinity d by dt of x t and e raised to the power minus st. By definition, we can write it further. If we take the limit both sides, the limit sx and minus x 0 negative, that is equal to integration 0 to infinity d by dt of xt. Now we can take the limit here because we are having s term here. We can take the limit s tends to 0, s tends to 0, and that is e raised to the power minus st dt we are having, right? So for that, we can just put the limit and find the value. That limit s tends to 0, that s xs and minus, here s is not there, we should not uh, that should not change our expression, so it is same one. So we are having this term, that 0 to 0 to infinity dx by dt xt. Now if I am going to put the limit here, so the limit makes it 1, right? Because e raised to the power minus st, we are going to put the value 0, so that is e raised to the power 0, that is 1. So further we can proceed with dt. Now in the very next step, we can have that xt after integration from 0 negative to infinity. So we are having the term here, limit s tends to 0 s xs minus x 0 negative, and that is equal to x infinity and minus x 0 negative. Now this cancel out this, and we landed with the situation where we can say that limit s tends to infinity sx, that is equal to x infinity. That is nothing but the final value theorem and expression has been proved. तो आपको वीडियो पसंद आया होगा, आप लाइक करिए, शेयर करिए, चैनल को